अस्सलाम वालेकुम बेटा। जो हमने लास्ट टाइम किया था रिगार्डिंग दिस हाउ टू असाइन ए पॉइंट ग्रुप, उसमें मैंने कुछ चीज़ आपको बता दी है जो यहाँ पे भी आपको दिखाई दे रहा है कि अगर सिर्फ रोटेशनल एक्सिस इज प्रेजेंट, इफ ओनली द रोटेशनल एक्सिस इज प्रेजेंट देन इट इज कॉल्ड एज दिस CN पॉइंट ग्रुप. ओके, फॉर एग्जांपल इफ इट इज दिस लोअर सिमेट्री then it is C1, CSR, CI. Okay, you can see also if group of high symmetry, that is tetrahedral, octahedral, C infinity V, D infinity H econohedral. इसमें क्या होता है कि the molecule is highly symmetric, highly symmetric. The number of symmetry elements in symmetry operations present in this molecule is very, very high. Similarly, if you see the higher order axes, some molecules have present the higher axis, higher order axis. For example, if the rotational axis is present, only the rotational axis is present, rotational axis and the this plane is present, then it is called as only the principal axis is present and the plane is present, that is called as CMV point group. If it has also presented this horizontal plane, then it is called as CMH point group. If the principal axis as well as subsidiary axis present, then we call the nomenclature is D point group. It may be the D, the order of the D point group will be the order of the principal axis, highest order axis. Okay. Now there are certain examples because I have given the detailed lecture on this how to assign a point group. Now we will do some this examples. For example, in low symmetry or no symmetry operations, जिसमें बहुत कम आपको symmetry elements देखने को मिलते हैं. For example is here. If you see this example, अगर हम इस example को देखेंगे, if it is a stage 4 molecule, then it is tetrahedron, regular tetrahedron, and it is highly symmetric molecule because tetrahedron is a point group, TD is a point group, and it has a number of these symmetry elements and symmetry operations present. Okay, so but here, if you see here, all the groups have been just replaced. H has been replaced. And there are all the four groups are different, and that is why no symmetry operation is present in this point group. That is why we call this as C1 point group. Why C1? Because when we rotate this molecule as 360 degree, it will be the original identical molecule. That is why it is no symmetry other than the identity operation, because identity is always present in the molecule. जब कुछ भी प्रेजेंट नहीं होगा तो आइडेंटिटी डेफिनेटली, क्योंकि जब 360 डिग्री पे रोटेट करेंगे तो डेफिनेटली वहां पे क्या आएगा, वहां पे आपको ओरिजिनल मॉलिक्यूल देखने को मिलेगा. Second, if only the mirror plane is present, then we call the point group as CS point group. Okay. For example, in this molecule, if you see here, you cannot draw the this C2 axis from this carbon to this carbon here this way, because in that case when you rotate this, अगर आप यहाँ पे देखेंगे भी बेटा, एक मिनट में आपको दिखाऊंगा. When you rotate this molecule in this way, अगर आप इसको rotate करेंगे in this way, तो यहाँ पे क्या होगा, Br की जगह Cl आएगा और Cl की जगह Br आएगा. That is not the equivalent structure. जो हमारा मतलब होता है, जो यहाँ पे हम एक्चुअली रोटेशन से हमें क्या मिलने चाहिए, इक्विवेलेंट स्ट्रक्चर या आइडेंटिकल सॉरी इक्विवेलेंट कॉन्फ़िगरेशन हमें मिलने चाहिए. और तो जब यहाँ पे Br Cl को रिप्लेस करेगा, Cl Br को रिप्लेस करेगा, दैट इज आइडेंटिकल, दैट इज नॉट द जस्ट इक्विवेलेंट कॉन्फ़िगरेशन. अगर यहाँ पे C2 ये वाली C2 डालेंगे, that is also not present because H को Cl और H को Br यहाँ पे replace करेंगे, that is also not present. That is why only plane, because this is a planar molecule. This is a planar molecule. That is why only one this element of symmetry is present. That is the this planar symmetry. This one. जब हम इसको ये वाला plane डालेंगे, that is the molecular plane also. Because just always remember this. When the molecule is planar, there is present a molecular plane. Okay. Whether it is a sigma V, whether it is a sigma H, depending upon the principal axis. But here it is not sigma V, neither it is sigma H, because the principal axis is not present. That is why we call simply this as the sigma. Okay. Second example. Next example is this. When you see the next example, this is only inversion center is present. Only the inversion center present. Because in these examples you should remember, because these are certain examples in which there is no symmetry. This low symmetry, this example is in which No symmetry other than this is present in version center. So remember this example also. For example, this staggered conformation of this. You know the eclipse and staggered conformation of ethane. It is a staggered conformation of this CHClBr. Okay. तो यहाँ पे क्या होगा अगर आप देखेंगे this Br will be when we invert this molecule, this will occupy this position, Cl will occupy this position, H will occupy this position. We will invert this molecule. That is why no axis of symmetry is present, no center, no plane of symmetry is present, only inversion center is present. Similarly, when you see here certain examples in which these are the highly symmetric molecules. For example, there is HCl. Remember these examples, very, very much important. High symmetry molecules containing many symmetry operational linear tetrahedral octahedral econohedral. For example, if you see this C infinity V, remember this example. Remember this example. Remember this example. This is the HCl. Okay, in HCl, this axis which you see here in this direction, this axis actually this axis when you rotate this molecule infinity times, आप इसको थोड़ा सा रोटेट करो, फॉर एग्जांपल 1 डिग्री 1.1 डिग्री 1.2 डिग्री, you will find there is an infinity times equivalent configuration. See, because it is a linear molecule, you can anything which is a linear, you can rotate it infinity times. थोड़ा सा point one आप change करते जाओ, you will find the equivalent configuration. That is why we call this as C n की जगह जो n यहाँ पे वो infinity है, because it is the infinity times you can get the equivalent structures. That is why we call this as C infinity. And जहाँ से infinity, जहाँ से आपका axis है, C infinity axis है, वहां से आप प्लेन भी डालते जाओ, तो वो भी आपको इन्फिनिटी टाइम्स है, इसलिए जाके यहाँ पे क्या होगा, यहाँ पे ये वाला प्लेन प्रेजेंट नहीं होगा, ये तो आपको पता है, दिस प्लेन इज नॉट प्रेजेंट, बिकॉज इफ यू सी दिस प्लेन, दिस एक साइड से एच एक साइड से सेल, इट्स नॉट प्रेजेंट, ओनली दैट वन इज प्रेजेंट. अगर आप यहाँ से डालेंगे इसके बीच में, तो वो भी आप थोड़ा थोड़ा स्ट्रेन करके आप इसको डालेंगे तो वो भी प्रेजेंट है, ये वाला प्लेन. ठीक है, तो these molecules are linear with an infinite number of rotations and infinite number of reflections भी याद रखिएगा. यहाँ से आप सी इन्फिनिटी डाल रहे हो, वहाँ से आप डालिएगा क्या भी रिफ्लेक्शन भी, प्लेन भी डालिएगा, इसलिए वो भी इन्फिनिटी टाइम है. कंटेनिंग रोटेशनल एक्सिस, दे डू नॉट हैव द इन्वर्जन सेंटर, इनको इन्वर्जन सेंटर प्रेजेंट नहीं होता है. तो सी वी इन्फिनिटी वी में आप एक एग्जांपल जरूर याद रखिएगा, HCl. इसी तरीके से डी इन्फिनिटी है, इसमें खाली ये वाला प्रेजेंट नहीं है, दिस वन सी इन्फिनिटी वाला नहीं, बल्कि इसमें ये भी प्रेजेंट है, बिकॉज व्हेन यू रोटेट सी टू एक्सिस इन दिस डायरेक्शन, तो यहाँ पे जाके ये भी ओ है, ये भी ओ है, इक्विवेलेंट है, तो आप इसको जाके रोटेट कर सकते हो. तो यहाँ पे भी आपको दो होंगे, सी इन्फिनिटी भी है, C2 भी है, तो कौन सा आएगा, ऑर्डर विल बी द डी, बट एन की जगह हाईएस्ट ऑर्डर कौन सा, इन्फिनिटी. दैट इज वाई वी कॉल दिस एज डी इन्फिनिटी. और प्लेन कौन सा प्रेजेंट है, अब देखिए, ये वाला प्लेन भी इसमें प्रेजेंट है. ठीक है, ये वाला प्लेन, जब आप इस प्लेन को देखेंगे बेटा, ये वाला प्लेन, और एक्सिस कहाँ से आ रही है, सी इन्फिनिटी एक्सिस यहाँ से आ रही है, परपेंडिकुलर है, तो जब परपेंडिकुलर है तो ये कौन सा बन गया, सी एच, सिग्मा एच. ठीक है, तो यहाँ पे सिग्मा वी भी प्रेजेंट है, इन्फिनिटी टाइम सिग्मा वी भी प्रेजेंट है, बट वो सी इन्फिनिटी जहाँ से है वहां से आप सिग्मा वी भी डाल सकते हो. दैट इज वाई दिस पॉइंट द पॉइंट ग्रुप ऑफ दिस कार्बन डाइऑक्साइड इज डी इन्फिनिटी एच, हाईली सिमेट्रिक मॉलिक्यूल. ओके, should remember this also. These molecules are linear with an infinite number of rotations and infinite number of reflection planes. Containing their rotational axes, they also have a perpendicular C2 axis, a perpendicular reflection plane, and an inversion center. Inversion center is also present in this molecule. Okay. Similarly, if you see the third tetrahedral, I will discuss it in detail in the next example. Definitely. If you see this tetrahedral has most but not all molecules in the point group have the familiar tetrahedral geometry. They have 4 C3 axes, 3 C2 axes, 3 S4 axes, and 6 sigma D planes. They have no C4 axis. S4 is there, but no C4 axis present. If you see this example, I will discuss it in detail in the next lecture, because here I am concise. Most I will do one thing, I will give a more and more examples in this video, and give only the concise information about these detailed simple operation of this molecule. If you see this molecule tetrahedral, please draw a cube. and kept keep the alternate positions, keep androgenate alternate positions of the cube. You will find the actual octahedron, sorry, tetrahedron. When you find that tetrahedron, then add C3 axis, 4 C3 axis, and then 3 C2 axis, and S4, 3 S4, and 6 sigma D. You will find all these symmetry elements present in that molecule. Okay. Similarly, in case of SF4, SF6, sorry, SF6 is the octahedral structure. These are the highly symmetric molecules. In this case, geometrical forms such as cube share the same set of symmetry operational. जो cube होता है उसमें भी इतने ही operational होते हैं. There are 48 symmetry operations present in this molecule. ठीक है. R 4C3 rotational axis है, 3C4 rotational है, and then inversion symmetry is also present in this molecule. Similarly, in case of this econohedral structure is this, and in this molecule there are 120 symmetry operations present in this molecule. For example is simple. You know this econohedral, icosahedral structure is example is B12 H22 2 negative. अगर आप इसको निकालेंगे भी तो that is very good closed structure. This will be definitely closed structure, I think so. In addition to these four, in addition to these four, this other groups are also this TH of octahedral, and this rarely seen in nature. These groups are discovered, so it is not necessary for the people. Next, rotational axis with the highest order of this rotational axis. For example, if you see the CN axis with the highest order, C5 axis, sorry, C3 axis. In case of PF5, this is actually a trigonal bipyramidal structure. Okay, trigonal bipyramidal structure. These three F are present in a plane. These three F are present in a plane, and this F and this F are present above the plane and the below the plane. This is a triangular structure. This is a triangle. This is a triangle. Here you see here. This is a triangle actually. अगर आप 3D में इसको देखेंगे, this is a triangle, and this triangle has upper side is one fluorine and the lower side is one fluorine. When you draw the C3 axis passing through fluorine, phosphorus, and fluorine, then rotate it 120 degrees, you will find the C3 axis. Okay. Similarly, this has the C3 axis. Similarly, in this molecule, CH3 molecule. This is the ethane molecule. Ethene name, but it is an ethane molecule. This molecule, when you rotate, also this is also C3 axis. Similarly, 1, 3, 5, 7 tetrafluoro cyclooctatetraene also has C2 axis. This molecule has C2 axis. This C3, if you see this molecule, I have shown you. See, I mean this actual structure is this. Okay. So in this molecule, if you see, this molecule has also C3 axis present. तो यहाँ पे जाके ये इधर जाएगा. अगर आप इसको ध्यान से देखेंगे, this जो यहाँ पे जाके ये मैं इसको कलर करूँगा. This one and this one are in the same plane, and this one just cross कर रहा हूँ. This one and this one is the same plane. Okay. So you will rotate this molecule at 120 degree and you find this equivalent structure. That is why this molecule has only present the C3 axis. Okay. Now the next example, we'll move to the next example. The next example is these examples are number of examples are there. You can see these examples. NH3 has C3 axis present. In case of this 1,5 dibromonaphthalene, it has also C2 axis present. C2 axis present. When you draw this axis, when you draw this axis, C2 axis is present in this molecule. C2 perpendicular to this, C2 perpendicular to the plane of the molecule. Plane of the molecule. Okay. See here. If you rotate if you rotate this molecule and pass the C2 axis through this here, where I have kept this cursor. If you rotate now molecule, it will rotate from here to here. It will be 180 degree, and when you go from this to here, it will be 180 degree. Oh, sorry, 360. So this angle is actually 180 degree, and when you rotate this molecule and the axis passing through this very much center, okay, in between this, and you will rotate the molecule. When you rotate the molecule, it will do the equivalent structure and the C2 axis present in this one. Similarly, in this molecule, this has also a C2H present. The axis is passing through this, where I kept the axis, where I kept this cursor. Okay, from when you draw the axis, जब मैं यहाँ पे एक्सिस डालूंगा कहाँ से, मेरे आंखों से जाके सीधे बोर्ड के अंदर से जाएगा दिस एक्सिस, जहाँ पे मैंने कर्सर रखा। अब इसको आप रोटेट करो 180, इट विल रोटेट, व्हेन यू रोटेट दिस मॉलिक्यूल फ्रॉम दिस टू दिस, ये यहाँ पे जाके यहाँ से यहाँ तक जाएगा। ओके, अगर फर्दर आप रोटेट करेंगे इसको तो वो 360 हो जाएगा। तो आप एक चीज याद रखिएगा, बट this molecule is the trans H2O2. There are three different shapes of H2O2. One is cis H2O2, another is open book type structure of H2O2. You should clearly know the structure of the molecule. Otherwise, you cannot get much information about this group theory. You should clearly know the geometry of the molecule. Okay. Now, the next example, we'll go through the next example. I will try my best to give the all the examples in the one lecture. Uh, this PF5, we have seen this in the previous this slide. This has C3 axis present and C2 axis also present. When the axis passes through fluorine and phosphorus, and it will rotate this fluorine and this fluorine and this fluorine and this fluorine. Similarly, when we this C2 is axis present, this C2 axis is present, and there are three C2 axes present, C3 and 3 times C2 axis, and that is why we call this as D point group. D point group we call this. Similarly, in case of this CH3, CH3, and COEN 3 plus, it has also present G point group. In these molecules, if you see in these molecules, they don't have any subsidiary axis present. This molecule have subsidiary axis present. That is why we call this as D point group. And but these molecules does not have any subsidiary axis present. That is why we call them as C point group. Okay, either C2, either C3, either C2 or this C2. Okay. So next example. If you see this, does the molecule have mirror plane? Now we'll see the mirror plane in these molecules. There are present some mirror plane. In this case, there is a mirror plane present. डी ग्रुप में अगर मिरर प्लेन प्रेजेंट होगा तो किस तरीके से, तो इसका पॉइंट ग्रुप जो होगा, यस मिरर प्लेन इज प्रेजेंट इन दिस मॉलिक्यूल, बट इन दिस मॉलिक्यूल नो मिरर प्लेन इज प्रेजेंट, नो मिरर प्लेन इज प्रेजेंट. Now, but in this molecule PF5, the Miller plane is present. That is why we call this a point as D3H. But in case of this 1,5-dibromine epithelium, yes, plane is present. That is why we call it as C2H point. But in case of NH3, CH2O2, and they don't have this mirror plane present, sigma H. Okay. Now see in the next, the COEN 3 plus, they don't have this. Is this have a sigma D present? No, they don't have a sigma D. That is why this called as D3 point only, because it has a C3 and 3 times C2 axis present. Okay, and if you see this example NH3, they have a sigma V present. Okay, sigma V is present. That is why this NH3 is called as C3V point. Next example is there SN2 axis. For this example, it's not necessary. Now we will see this. This example I will show. If you pass this rotational axis from the center of the bond and rotate this molecule, it has C2 axis present, and also when you see the plane will be this. See here. See here. See here. See here. This plane, because this molecule is a planar molecule, and this plane is present. This plane is present in this molecule, and axis passing through this center of this. कहाँ से बोर्ड के अंदर जा रही है और मेरी आंखों से आ रही है और सीधे बोर्ड के अंदर जा रही है. The axis जब यहाँ से axis पास होगी between the center of this bond, तो यहाँ पे ये plane जो बनेगा that will be the sigma h. That is why this plane has present this sigma. This C2H, C2 is present, sigma H is present, that is why we call this point as C2H point. Similarly, in this case, this says C3X is present and the sigma H is present, that is why we call this as C3H point. Okay, if you have confusion, you can call me and I will explain you fully. Similarly, in case of this CNV point group water molecule is the example of this C2V. And similarly, if you see all these C3V, PCl3 have a point group of it is similar to that of NH3, and it has a point group of this C3 point group. Similarly, square pyramidal shape BRF4, square pyramidal shape BRF5, okay, sorry, BRF5, it has a polygon of C4 because the axis passing through here, fluorine and bromine, and it will rotate 90 degree, and it is a C4 axis, and here it has also present four times sigma V present. That is why we call this as C4V. But no subsidiary axis is present, only the principal axis is present. Why? If fluorine will be in the lower side also, then it has the subsidiary axis present. Then we will call them as octahedral shape because if the fluorine will be present in the lower side, then it has a different symmetry element is present. But due to the only one side fluorine is present, subsidiary axis is not present. Only the principal axis present, that is the C4 axis. No C2 axis present. If you draw the C2 axis from fluorine, bromine, and fluorine, when you rotate, this fluorine will go further down. And this is not the equivalent structure. That is why this molecule does not have any subsidiary axis. Similarly, there are a number of examples in which the point group is C infinity V. For example, HF, CO, HCN, all these molecules have the point group of C infinity V. Remember these molecules because these molecules commonly are asked by the interviewers what is the give the examples of the point group having C infinity V. Okay. Similarly, if you see in this molecule, the N2H4 has a gauge conformation. You should know the conformation of this molecule also. Okay, this molecule does not have only C2 axis is present in this molecule. No any other simple element is present. I have discussed with you that this example PCl3 on the blackboard, but I could not just draw this BCl6H53 tablet. I could not fully understand you people about this example. If you see this example, this has three blade propeller distorted out of the planar shape by the lone pair on the phosphorus. Due to phosphorus of lone pair, the structure of this C6H53 is this. That is why this does not have any plane present. Only the C3 axis is present. Only the C3 axis is present. No plane is present in this molecule. So the point group of this molecule is C3 point. Okay. Okay, now DNH point with a number of examples. You can simply, very simple. D3H point with BF3, I have discussed it in detail. I have discussed in detail because these examples are your syllabus. That is why I detailed to discuss these examples. BF3 has C3 is present, 3 times C2 is present, 3 times sigma V is present, and also sigma H is present. Okay, so that is why this molecule has the point group of DNH, minus D3H is present. We have three molecules. D4H is present in case of PTCl4 because it has a C4 axis, it has a 4 times C2 axis, it has a 4 times sigma V, it has a sigma H also present. That is why we call this as DH because subsidiary axis is present, principal axis is present. That is why we call it as D, and highest axis, order axis is 4. This is why we call it as D4, and sigma H is present. That is why we call this as sigma just D4H molecule. Similarly, if you see the sandwich compound, osmium, this dipentadienyl eclipsed conformation, this has also D5 H point because if you see this molecule is a planar, here you will see easily where it is bonded with this when we draw the line from this molecule between the center of this circle, we will find the C4 C5 axis, and we rotate it as in this uh, almost just when we rotate this molecules, there is the axis called as C5 axis. There is also 5 times this C2 axis is present in this molecule also, and this molecule has D5H point. Similarly, in case of benzene I have discussed it in detail. Benzene have this C6 point group when we draw the axis between the center of the circle of the benzene. When we rotate the molecule with 60 degree, we find the equivalent structure. And there is a operation of C6 1, C6 2, C6 3, C6 4, C6 5, C6 6 is the equivalent structure. Okay, and there are 6 times C2 axis also present. That is where D comes. D6, and there is a planar structure sigma H is present because this is sigma H and axis passing through this center and perpendicular to the principal axis. That is why this is called as sigma H. Okay, D infinity H F2 molecule is N2 molecule is there, and also the CO2 molecule is there. Yeah, C2H4, a steady molecule has a D infinity H particle. There are, I think, there are number. These are enough examples. If you could focus on these examples, I think you don't bother anything about other examples, because if you go through these examples very well on your notebook and draw all these symmetry elements and symmetry operations of these examples, your group theory will be very, very clear. But once you can do this exercise, uh, then you can find this group theory is very easy. Otherwise, if you cannot do the paperwork, the group theory is very tough. Then remember this, because it has, you have to visualize the 3D. You cannot you cannot focus you that is this yeah, in this two-dimensional structure. You have to focus on three-dimensional structure of the molecules. You have to visualize that molecule will be in this shape. When you visualize the molecule in the actual shape, then it is very, very easy for the person who visualization power is very, very good, who can visualize the molecule, actual molecule is in the shape, and shape axis is present in this. Here we can draw the molecule. Here is a rotational axis. There is a plane present. Those students can cover this very easily. But I will suggest all these students, because all students are equal. If you do the paperwork of this exercise, all the examples of this, you will draw the rotational axis, you will draw the plane of symmetry, you will draw the inversion center, you will draw the improper axis of rotation. Your this concept will be very, very much clear if you do all the examples. Okay, it depends upon you people now. Then another example, that is the allele. I will show you the 3D structure of allele definitely. I will give you a link where you can visualize the 3D structure of this allele. This allele has three C2 axes. How many C2 axes? There is C2, three C2 axes. But the principal axis will be one which is present, which will go through the number in which you have the number of atoms will be maximum, because all are C2 axis. And which one is the principal axis? Because we know the exam, just the definition is this, which have highest order, we call them as principal axis. But in case of allene, there are three C2 axes, and in which situation we call as principal axis and which is the subsidiary axis. Simply, the nomenclature is this: the C2 axial which will pass through maximum number of atoms is called as the principal axial. Okay, the principal axis is this one. This one is the principal axis, because it will pass through this carbon, this carbon, and this carbon. And other C2 axes are passed through only this C2, which is the central C carbon atom. That is why this axis is called as this principal axis. And there is also a dihedral plane present in this molecule. Uh, that is why we call the point group as this D2D. Similarly, there are a number of examples of D4D and nucleosine in case of stagger conformation, or there is a stagger conformation of this ferrocene. This is also D5D point group. Similarly, D3 point group, there are a number of examples. Other examples are there, which are high point group D3 example. D3, only D3 is present in this point group. Okay. Rest examples we'll see here. XCF4, XCF4, the structure of XCF4 is this. C4 is present and C2 is also present. And D group is called, it is called as D4H point group. Similarly, SF4, SF4, the structure of SF4 is this. C2 is present. Okay, when you rotate the molecule as 180 degree, then the axis passes through the sulfur, only through sulfur and this lone pair. Then rotate the molecule 180 degree. You will find this equivalent configuration. C2 is present. No C2, CS, what is called? No, I leave it. And sigma V is also present. That is why we call this as C2V point group. Similarly, there is also other examples are IO F3 example. The point group is in this case the point group is I think CS should be 180 degree. It will rotate 180 degree, but it cannot Yes, this molecule does not have this point group. It has only sigma H present. It has only sigma H present, to no rotational axis present. That is why we call this the point group of this example is CS. Okay, let's go to 6. There are a number of other example cases. Look, C2 axis perpendicular to the highest order axis. Okay, and C2 axis perpendicular to CN axis. No C2 axis perpendicular to CN axis. C classification or D classification. DNH, DNDG. I have detailed. I have discussed in detail how to assign the coordinate. Okay. There are other examples, but I'm not go through these. You have seen this C3 INHC coordinate, different operations. For simplicity, the slide is for simplicity we will make the NH3 in this way. When we rotate this molecule at 120 degree, we will find this. Okay, it is for simplicity. Otherwise, the structure is pyramidal. So that is a point with how you use the point with matrix. Thank you so much for watching this video. I once I will take the another lecture for this class. What is class? What is order of this class? Okay, thank you so much. Do one thing, exercise these all examples and draw this rough copy and do exercise.